And hello YouTube, welcome back to this video on Salome OpenFOAM FreeCAD. Okay, excuse me, OpenFOAM Intermediate. So in the last video, we were experiencing some problems with the meshing issues and result. Apparently have a lot of support and very appreciative of it, and someone even suggested that I use Gmesh, or rather use this automatic meshing scheme, but this person XA change it to Gmesh and it works, which is great for him or her. Okay, for now, I don't that Gmesh didn't work for me. Okay, so I'll just roughly walk you through the debugging process, and then after that, if I have extra time, then I'll share with you the stuff I learned along the way. Okay, for example, dealing with this meshing interface. So let me go through the bugs one at a time. Okay, so I'll go to maybe this thing called video tutorial. I'll use not Paravis, not Paravis, but let's go to the mesh toolbox. Okay, I don't want to load ParaView now. Then after that, I will just click show, right click the geometry and show. And of course, I can show the mesh as well. Okay, it'll take a while. Let it run. Oh wow. And then I want to delete. I want to delete this, close this ParaView. Now I want to delete this scene, ParaView scene. Yeah, okay, so you see, I was able to get this thing working by changing the mesh generation algorithm slightly. Basically, the idea is to make it, more fine. The idea was to make it more fine, and that actually eliminated the problem of intersecting triangles. Now, then I also had to export this geometry. Okay, so what I did was I right-click this, for example, 3D experiment, whatever it is. Okay, then I had to go to the export and export as a UNV file. Okay, so let's just check how many mesh elements it has, how many cells this thing has. To do that, you go to 3D experiment, then you press evaluate. It has 2.5 million cells. This is way too much. Okay, it's almost like that will take at least about 4 gigs of RAM at the very least, just to do simple calculations. Okay, that's a lot. You don't want anything above 1 million generally, unless you're doing very high fidelity simulations. So I was wondering, why is this thing going on? But first, I had to export this. Let's export this. Okay, UNV file, and heat exchanger netgen 2.5 million points. Okay, 2.5 million points. So that's a lot of points. Okay, then after that, I will slowly, get its stuff done. Then I will go to my Salome directory where I save all these things. Of course, you realize that these aren't small files. I can do DOSH and star, and you'll see that these files will be in the order of 100 to 200 megabytes. This is not small at all. Okay, so this thing is still exporting. I should have to wait for it to finish. Okay, I should have to wait for it to finish. So if I keep going, you'll see that the heat exchanger netgen 2.5 million points, it's actually increasing. Of course, if I just want to keep doing this again, I can actually type in this command to actually keep track of the file size over time, and then it will just kind of update every 2 seconds as this file grows. Okay, that's a very interesting thing. You can just type watch. These are for Ubuntu Debian systems. But anyway, I digress. It should be finished when this waiting cursor is done. Okay, and once that is finished, I can then I can then bring this thing over to my directory in OpenFOAM, and then start using the ideas to UNV file. Okay, so go to intermediate plus NgEx mesh, and then heat exchanger Salome, and let's just paste it here. Okay, I have a 1 million points one because I tried many times. So over here, okay, over here I can open this in my terminal as I'm doing. I just run an all clean, the all clean script, and that will clean everything up here. Yeah, I do this ideas UNV to foam after exporting and changing all this stuff. Ideas UNV to foam, and let's do heat exchanger, blah blah blah. Okay, so it's 2 million points, so it'll take a while again. Okay, so I let it run, give or take 3 minutes. Okay, so I'll fast forward this bit. Yeah, okay, it's done. Okay, sure. So you have 3 patches here: inlet, outlet, and wall. Okay, inlet, outlet, and wall. All of these are patches. But of course, you have to kind of rename the patches. As you can see in polymesh boundary. Okay. The patches are called inlet, outlet, and wall, which I don't really want to name it inlet, outlet, and wall. Reason being, in all my 0 directory files, I call these okay, I guess inlet, outlet, and wall does work. Okay, then I'll just have to put this I'll just have to put the wall thing here. Or I can just rename the walls as tubings. That's fine. Okay, and I also have to change the boundary type from for walls from patch to let's say wall, so that we can use create patch dictionary, the create patch utility to do that. I've already went through that in a few videos prior, so I'm not going to go through it again. Alright, so that's basically the idea. And when I open it, okay, I'm going to reopen it. I'm opening this okay, let's see, I'm opening this in ParaView. Okay, so I need to, before doing that, yeah, so yeah, basically I need to touch a Salome.foam first. Okay, so I go through the summary first, touch Salome.foam, and you see this ideas UNV to foam is done. It will just make the mesh for us, so no need to do block mesh or anything like that, which is great. You can do the Salome.foam and it will load up everything for us. Okay, a very fine mesh. So let's do a surface with edges. We'll see more or less the same things, but one thing to note as you zoom in, you'll notice this excuse me, you notice this extra little cylinder inside, or almost a line looking like thing, and you notice that the other cylinders, the other what do you call that, pipes, don't have this extra little thing in the center, which kind of puzzled me for a bit. Then I was wondering why, and what I found out was that in my FreeCAD file, my center cylinder actually had this little hole in the center, which was not supposed to be there. Okay, this wasn't supposed to be there. So basically, where did this come from? It came from the what do you call that? It came from the sketches which I drew, particularly this one, the semicircle sketch, which there was a revolution, and actually I left a little circle in the center there. Alright, I left a little circle in the center there, and then I went to extrude the pad, which was bad. Okay, I left an extra little semicircle right in the center here, which I just deleted. Okay, I just deleted, and I found that out and just deleted it. So I'll have to kind of redo my FreeCAD paddings, then get back to Salome. Okay, so in summary, what actually happened? There was this little extra shape here, and that was actually that actually required a way finer mesh to resolve, and that's also why you had this intersecting triangles problem. So the intersecting triangles problem was made by an overly coarse mesh due to this little circle thing in the center. All right, and to solve that, I had to change some settings in Salome. So since I have about 10 minutes remaining before I hit the 20 minutes mark, let me show you how roughly I did this thing. Okay, so I'm going to delete this. All right, because I don't want this I don't want this Paravis module here. Okay, never mind, I'll leave it there. All right, so yeah, we have this mesh, we have this of course, and we have this pet 003 with the little erroneous shape, little hollow cylinder in the center, which was actually causing the problem. Okay, what then can you do? Well, you can go to mesh and create mesh, and I mean, I kind of didn't explain the way that this was supposed to work, so I can call this experiment 3D 2. Okay, so this actually creates an empty mesh file. Of course, this has not been calculated or anything, and I did not add any hypothesis. So if you accidentally close, or you want to close and edit later, what hypothesis to use? You go to the left hand side, right click your mesh, and you click edit mesh, and this will allow you to edit the mesh as and how you please. So normally we just did automatic hypotheses, but I'm not going to do that. What I'm going to do instead is try and go through roughly what netgen and even gmesh, what their rough algorithms are like. Why do we have this 1D, 2D, 3D thing? So the idea behind mesh generation is, let's say you have a cylinder here, right? You have a cylinder here. Okay, I'll explain all these markings later. So what Salome, netgen, or even gmesh will try to do is they will section this cylinder in terms of length by 1D elements. Okay, so in this direction, they will try to cut it up and discretize it. Okay, and that's how they generate the 1D mesh. Maybe they do it for this side as well. After you get the 1D mesh, they will try to use that as a base to generate the 2D mesh. So you have a 2D mesh over here as well. Okay, all of this will be done, and once you have the 2D mesh, then you go and generate the 3D mesh. Okay, you will generate the 3D mesh using the 2D mesh as a base. That is how most of these mesh generators, especially the tetrahedral mesh generators such as netgen and gmesh, that's how they do it. Okay, these are tetrahedral meshes. So let's say I want to generate a tetrahedral mesh. I can click tetrahedral mesh and it will remove some options, because if I put any under 3D, I will have body fitting as well, and that's another algorithm altogether. I'm not going to talk about that, but let's do the netgen way. So instead of doing netgen 1D, 2D, 3D, I'll just put netgen 3D. So when I put netgen 1D, 2D, and 3D, everything is kind of packaged in a box, in a sense that you will just have to edit one set of settings. So you just edit the 3D settings over here. Salome will do everything for you. If you want more control, like me, for example, I can do netgen 3D here, but then I will need to specify a 2D mesh generation algorithm. So I can either do netgen 2D or netgen 1D 2D. Netgen 2D will only do the 2D part, then I will need to decide on a 1D generation mesh generation algorithm, which I will not do. I will do netgen 1D 2D to simplify the process. Okay, so I will need to decide on the setting to generate my netgen 2D parameters. Okay, so I'll do 2D, I won't say 2D, maybe max 41. Okay, because it's the size of the max and minimum meshes are here. Min 0.05, and I'll just use moderate. Okay, and that will be done. And let's just do the 2D part first. Okay, I'm just gonna do the 2D part, and let's see whether I can compute. Okay, so it's gonna take some time to compute the mesh. Alright, and this is successful. This is successful. So I'm gonna close. And since the 3D part has been 2D part has been run already, and remember in the middle of this mesh there was actually an extra little hole in the center that wasn't supposed to be there. But since the 2D part is run, I can start to edit the 3D part as well. So I can do netgen 3D here. I don't do netgen 1D, 2D, 3D because that only allows you to control the 3D settings using this hypothesis part. Okay. Of course, there are other hypotheses you can add as well, such as this thing called viscous layers. That's a boundary layer addition. I'm not going to do that now. That one I will cover maybe in a later video when I have more time. But basically, based on this netgen 3D parameters, I can edit, and what I can name this is max 41, min 0.05, and instead of moderate fineness, I change. What worked for me was to change it to very fine or fine setting. So 0.05. Okay, so max 41, which is here, min is 0.05, which is here, fine is here. So I'm naming it as such so that I can use it for easy reference later. And in case I want to change the hypothesis, I can go to the scrolling down here. I can go to the bar here, and I just click the one that I want. So instead of netgen 3D parameters 1, 2, 3, 4, blah blah blah, using these hypotheses using the drop down menu with the appropriate name is way more descriptive. Likewise for this, you see my naming conventions are here, and you'll see only the 2D hypothesis show up. So I can just click apply, and close. And what I do, I can compute, and you'll see that it jumps straight to 39. Okay, right, what do we see? We have a bed input mesh, we have intersecting triangles. netgen 3D shows this. So where these intersecting triangles come from? They actually come from the 2D mesh, because it says, you know, the 2D mesh is the input for the 3D mesh. So the problem is with the 2D mesh, and I'll need to make it finer. So let's change the netgen 2D. Okay, so to edit this existing one, or to create a new one, I want to create a new one because I want to make it fine, not moderate. Okay, so I want to make it fine here. Okay, if you want to edit the existing ones, you can use this button here to the right of the gear icon. If I want to make a new one, I'll just use the gear icon there. So this is max 41, min 0.05, and I'll use a fine setting. Okay, so I'll click OK and apply, and this will be apply as well. Oops, I forgot to rename it. Yeah, I can't rename it after doing that, but well, I can apply. And the way to rename it, I guess you can change this. Okay, guess you can change it here. Use F2. Yep, that will help you to change your algorithm, and you can just compute. So you have to start from scratch again. So you'll be very slow this time because I increased the number of mesh elements by a lot, and that's how I actually generated such a mesh with 2 million plus points, which is not ideal. So okay, so it looks like this part's done. I have 130,000 elements for the 2D, which is way too much, in my opinion. But it works. It was able to resolve it because I had this small little thing in the center. So after that, I mean that's basically how netgen works, or Gmesh for that matter. Because even Gmesh has a 1D, 2D mesh, I mean a 2D and 3D mesh generation algorithm. So yeah, I'm going to kind of skip this part. Alright, I'm going to skip this part of the mesh generation, and I'll be back and roughly finish the video from there. Okay, so we are finished. And there are like, how many? 5173275 5 million points. That is way too much. Way too much. But it's a successful meshing process. Okay, it's a successful meshing process with 5 million points. I don't know why they keep growing. Yeah, but this is what it is. Let me close this. Yeah, so once this is done, you can export as per normal, a UNV file. Instead of this, you have a 5 million point, which I will not be using, obviously, but I'll just demonstrate how it's being done. Yeah, I was just demonstrating how these files were being generated. These UNV files, it will take a while to export, but that is basically made in the same way that the netgen 1 million and 2.5 million points file are being done as well. So you can play around with these settings to see if you have a very small complicated shape you need to mesh. You can do that. And of course, I will need to update this file to kind of get rid of this center thing. Alright, this center cylinder over here. Need to get rid of that, and that should actually reduce the number of mesh points significantly. Then after that, we can talk about polyhedral meshing and everything. But that's all I have for this video. Where we went through, what went wrong, and yeah, what went wrong and some ways to fix it. And hopefully in the next video, yeah, I will just edit this FreeCAD file to get rid of the unwanted feature in the center, that little circle thing. And yeah, basically that's done. I'll also show you how to use yeah, basically after that you do this ideas UNV to foam, and it will generate your poly mesh file for you. So that's all there is to meshing, at least the netgen way. Alright, thanks for watching. I'll see you guys again. Bye bye.